on this. We have discussed the basics of quantification of element last week. What we have to do is today to we have discussed the basics of quantification of element. We have to go with the some questions today. I thought of giving you simple questions, very simple questions, and then go on, right? Because shall we discuss something like hard, the tough one, forgetting the simple one. So as a result of that, some children might think that, my goodness, so we can't answer these questions because they are very tough. And actually, no. What we are doing is touching the high end, right? Okay, we'll discuss the simplest one and then go on. The thing here is that automatically I shifted into this hard one. Okay. Is it okay to continue with the same lesson or should I start a new lesson? Continue with the same lesson, quantification of elements, or should I shift to the new one?
Same lesson, okay, sir.
Yeah, thank you. And now, basically, we know this is a combination of the lessons with chemical reactions as well, because when chemical reaction, because you know that I will give you a little introduction how this the nature of the questions are built up, and then it goes on. If you consider that chemical reaction, like for example, we see magnesium, right? Should I share the screen with you? Oh, nice. If I say magnesium, right, react with hydrochloric acid will make magnesium chloride and hydrogen gas. So that is the normal chemical reaction. Magnesium with hydrochloric acid, magnesium chloride and hydrogen gas. Now, sometimes there are students who can't understand how I wrote this magnesium chloride like MgC rather than writing MgCl. Why did I put MgCl2? And how this hydrogen is removed. Um, and magnesium took chlorine and hydrogen was displaced. Why is that? So the answer, actually the answer is first one, you should, if you don't know about the valency number, then you can't understand this one. You should know the knowledge, you should have the knowledge on valency, valency, valency number. The other one, this displacement one, then you need to know about the activity series. Activity series. If you know about the activity series, then it will be fine. If you know the activity series, right? In the activity series, there are positions. The higher the reactivity of the metal would get a chance of displacing the weaker one. So it depends on it depends on the relativity. I mean the position that that particular metal is there. Now, once you arrange this chemical reaction, next one is balancing it. Balancing means we are trying to find out the amount of moles react with the other particular reactant in moles, the amount of moles. If you say, if this is not balanced, we'll see whether this is balanced. Normally, I start balancing from this main product, magnesium chloride. So you have one magnesium. Perfect. But two chlorine, here only one chlorine. Whatever the amount reactants are there should be with the product there, should be tallying with the reactants as well. So then magnesium chloride will have two chlorine. And I will be putting number 2 here, which indicates that you can't put, telling that Cl2, you can't put here 2. You can't do it because if you put this one, it indicates that the structure wise you are going to change that. Hydrogen flow with hydrogen 1 atom, chlorine 2 atoms. No, it is wrong. We are not going to put the 2 there. So 2HCl. Now, then there are 2 moles of hydrochloric acid. Magnesium chloride, okay. Now we see a number of hydrogen atoms, H2, 5. Now, this indicates that magnesium 1 mole, magnesium 1 mole, hydrochloric 2 mole, magnesium chloride 1 mole, hydrogen 1 mole. Right. Now, that step is also okay, completed. Then the relationship between the number of moles and the mass, moles and mass. That relationship is brought up by using the equation. Number of mole equal given mass divided by molar mass. Number of moles, amount of moles is equal to given mass divided by the molar mass. Now, somebody might find it hard. Every day I hear, what is the molar mass? The molar mass is taken by 2 ways. That is where we are going to connect with our quantification of elements, right? How? When you go, simple M equal, simple M over capital M, where capital M is the molar mass. Molar mass. Molar mass means the mass of a mole. Mass of a mole. So the mass of a mole will be in 2 ways. Mole of a mass will be in 2 ways. My friends would tell me what they are. Here, if you are brave enough to give me the answer. What are the 2 things that we have to consider here? 1. Anybody who is clever enough in telling me the answer would be mostly welcome. Yep. Molar mass. Mass of a mole. There are 2. What are they? No idea? No idea? How? How nice to see in the morning, Pawan is free. Yeah.
Atomic molar mass.
Very good. Savindu, the other one?
Molecular mass.
Yes. The compounds can be existing in the atmosphere in 2 ways. It may be atom. It may be atoms. Example, hydrogen, oxygen, hydrogen, oxygen, nitrogen, carbon, right? Or they may be molecules. Molecules. Example, H2, O2, N2, combination of carbon and oxygen, carbon dioxide, right? They are molecules. Molecules make compounds, and the matter exists in the environment as compounds. Now, we have molar mass of atoms, then we call them atomic molar mass. Atomic molar mass. Second, molecules. You got molecular molar mass. Atomic molar mass and molecular molar mass. The mass of one atom. Well, the mass of atomic molar mass means one mass of one mole of atom. So then how can you find it out? How can you find it out? Something like this. If you consider the atomic molar mass, you have to consider the relative, 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 relative atomic mass, relative atomic mass. That means mass of a given atom related with another atom. We considered that one by using C612 isotope. C612 isotope. And I got C612 isotope. So we discussed this one last week in detail. If you have missed it, you can go to my YouTube, right? If you don't know the path, if you are a new student who is watching this one, can go to anuradhsir.com, and from there you can go to anuradhsir.com, and from there is a YouTube channel. You can find out the path. Right, isotope is there. Relative atomic mass, isotope, according to this one, now we have find out the relative atomic masses, like getting like this. Mass of a given atom, mass of the given atom divided by mass of 112 P12 atom. And after the calculation, all these masses are given, or relative atomic masses are given, like oxygen 32, chlorine, oxygen 32, then? Is it 32 or 16? Oxygen 16. I made a mistake. Or oxygen 16, chlorine 35.5, Na 23, right? So some of the hydrogen 1, calcium 40. So the atomic masses are given normally when a question based on this area, the relative atomic masses are given. Or else, now we became smoothly in a path connecting, right? We just started like here. We started by giving you a chemical reaction. When in chemical reaction, we are doing balancing it according to the what's that yeah, I can't remember that one. Yeah. If you can tally this one with the law of conservation of mass, according to the law of conservation of mass, whatever the amount of reactant should be in the amount of product, if the chemical reaction occurred in a closed system or closed environment, then balancing means you tally all the reactants with the product. It means the amount of moles that contributing or was found out. And now we want to talk about the mole, the relationship of mole with the given mass and the molar mass. This is the place where I'm going to discuss as a question today. So the given mass, the relationship was introduced like here. What is capital M? That's molar mass. Molar mass was found out in two ways: the atomic molar mass and the molecular molar mass. Atomic molar mass is considered by finding out from the relative atomic masses. So the relative atomic mass is found out by mass of the given atom divided by the mass of 1/12 of the C612 isotope. And we have been given, after calculations, their relative atomic masses, and in equations, those are given in the test paper itself. So now, the mass of one mole equal mass of one mole, mass of one mole equal relative atomic mass considered in gram. If you consider the relative atomic mass in gram, for example, oxygen 16, oxygen 16 gram, there you have 1 mole. You got 1 mole in 16 gram. And according to the Avogadro, the amount of atoms in 16 gram is 6.022 times 10 to the power 23 atoms. So it is expressed in two ways. The 1 mole mean, the amount of substance which has 6.022 times 10 to the power 23 amount of atoms or molecules. The amount of the mass of a substance which has 6.022 times 10 to the power 23 amount of atoms or molecules, there you have 1 mole. That's also in that way also we can express. Now, then we consider that N equal simple N more capital N. I just went on only with the atom, atomic molar mass, and went on and discussed and told. And then I'm going to select the molecular molar mass. Molecular molar mass. In the molecular molar mass, in the molecular molar mass, like this. Now, we are going to find out, we are going to relate with the Avogadro's concept. Avogadro says if you consider 6.022 times 10 to the power 23 molecules, for example, carbon dioxide Carbon dioxide 6.022 times 10 to the power 23 is there. Are there? Where you have 1 mole of CO2, or the mass, if you consider, where 6.022 times 10 to the power 23 carbon dioxide molecules are there, its mass is considered as molecular molar mass. Molecular molar mass of 6.022 times 10 to the power 23 of CO2 is equal 44 gram, equals 1 mole. 44 gram. How did you get the 44 gram? From where did it come? Well, 44 came something like this. Now you have to consider the molar mass, molecular molar mass, which is considered as simple, capital M, simple R, Mr. The Mr is equal Mr. Carbon dioxide, Mr. Carbon dioxide is equal carbon, AR, relative atomic mass of carbon, plus decac 2 times AR of oxygen. Now we know AR of carbon. AR of carbon equal 12. AR of carbon is equal to 12. It is given. AR of oxygen equal 16. So the value of this one then 12 plus 2 times 16. That two together give you 44. MR, relative molecular mass of carbon dioxide is 44. Dioxide is 44. That is how I got 44. And if carbon dioxide molecules 6.022 times 10 to the power 23 are there, the mass of it is 44 grams, and the number of moles there is 1 mole, and that indicates the molar mass. So the molar mass is 44 grams per mole. And that is what we want to come over here. And I'm going back to that equation. The place where you put in trouble. What's it? Magnesium. Magnesium reacts with hydrochloric acid and makes MgCl2. Hydrogen gas is released. When balancing it, 1 magnesium 1 Cl2, so I put 2, and then hydrogen 1 mole. For the other one, now if you have this one, right, express this one in moles. So you get 1 mole, 2 mole, 1 mole, 1 mole. Express it in mass. Express it in mass. Right. Magnesium. What is the relative atomic mass of magnesium? I remember. What is the what is
24.
magnesium? What is
24.
24? Relative atomic Show me masses of RST 20 elements. Relative atomic masses of first 20 elements. Did you get that idea? Find it out, locate. Magnesium. There you have. This will be important. This will be important to us. Can you see that? Can you see this?
Yes, sir.
Yeah. So you can have hydrogen 1, atomic number, atomic mass. Yeah, atomic mass is relative to atomic mass. Hydrogen 1, helium 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, chlorine 19, neon 20, sodium 23, magnesium 24, aluminium 27, silicon 28, and phosphorus 31. Sulfur 32, chlorine 35.5, argon 40, potassium 39, and calcium 40. So the little kids, they are very much happy to hear me that expression sulfur, sulfur. It's not sulfur, right? Why is it? If Irish people say sun, soon for sun, why can't we, right? Okay, I'm going to select now. Express this one in the masses. Right. Magnesium 24 gram. 24 gram. Hydrochloric. How many grams? 135.5. That means 36.5 grams. Magnesium chloride. You are very clever at maths. Could you please tell me the amount, the mass of magnesium chloride? Okay. 24, 71. 71, 24. 35.5, 5, 95. Right? Yeah, 95. No? But you are silent.
95, sir.
95. Okay, hydrogen, 2 grams. If you are expressing the molar mass, you have to say 44 gram per mole, 36.5 gram per mole, 95 grams per mole. I didn't write like that. So if you are expressing the masses that contributed in this chemical reaction is like this. And if you consider the amount of the moles here, the masses are here. Now the question is made from there, right? That means you can use N equal M over M, N equal M over M, N equal M over M, N equal M over M. That means you can ask anything from here, right? Or from here, right? This is not, of course, used. I will show you how it is done. Now, I'll show you how it is done. Example. The given below is a chemical reaction. Given below is a chemical reaction. Now I'm going to share my screen with you. Shall I share it or will I keep it in the same way? I will share for you to have a better vision. You can have it, right?
Yes, sir.
Now let's see. Yeah, given below is a chemical reaction. Put use it and answer the question. Answer the question. Now, this is the chemical reaction, right? The chemical reaction is this one. I'm going to take which one? The magnesium one. Magnesium with hydrochloric acid makes magnesium chloride and hydrogen gas. Hydrogen gas. My simple question. The above equation is not balanced. Balance it. Balance it. So now you know how to balance it. How are you going to balance it? Yeah. Magnesium hydrochloric, magnesium chloride, hydrogen gas. So you have to have two hydro. That's correct, right? Second one. Mention the state. Mention the state of the reactants and RE reactants and products. Mention the states of the reactants and products in the equation. So how are you going to mention that one? Magnesium. Now, what does it mean? You have magnesium, 2 hydrochloride, magnesium chloride, hydrogen gas. So hydrogen gas, magnesium solid. You consider solid. Hydrochloric, what should I write here? Could be liquid, gas. Should I write here? What should I write here? Aqueous, AQ, because it is a solution mixed up with water. Magnesium chloride is also aqueous. Magnesium chloride, aqueous, hydrogen gas. Okay, my next question. Moving to the third one. That's the application of the ones that we have been learning right now from 4 o'clock in the morning. Look at here. I told you that I'm going to I'm going to get this equation to make the question based on this. This equation to make the question based on this one. Right. Now, if right, I told you that I will give you so simple question. How many moles of of magnesium are used in this experiment? How many moles of magnesium are used in this experiment? The answer, the answer, the answer.
1 mole.
All you. How nice to hear a girl's voice in the morning. One more. And the next one. Fourth one. If now you're going to put into trouble. All right. Now look at here that I'm going to make the question by using this one. I told you magnesium chloride 95 grams. I considered this one in masses. So I consider this one in masses. I considered this one. I express in moles and the question asked by using that. I express in masses and I'm going to express in masses. So simple question. How many, how much, so what is the mass of hydrogen produced? I can ask, right? What is the mass of hydrogen produced? I'm going to add out. Very simple question. If if 1 mole of if 1 mole of magnesium chloride is produced. If 1 mole of magnesium chloride is produced. Simple A. What is the mass of magnesium chloride produced? What is the mass of magnesium chloride produced? The answer is, what is the mass of magnesium chloride produced? What is the answer? What is the answer? Hello.
95 grams. 95 grams.
Yeah, magnesium chloride 1 mole is produced as as N equal M over capital M, given M, so it's asking M equal simple N over capital M. Simple N is 1, that's 1 mole. Capital M is the molar mass. MR of MR of MgCl2 equal AR of magnesium to AR of Cl2 to AR of Cl2. AR of magnesium is 24. 24. 2 AR of Cl2 is 2 times 35.5. And now 24 plus 71. That means 95. Now, magnesium chloride's molar mass, relative molecular mass is 95. So the molar mass is given is there. This I can write with the I can do it here. I can write number of moles, 1 mole. 1 mole. Can you see this board or should I share the screen?
Can see.
Right. 1 mole and times molar mass 95 gram per mole. 95 grams per mole. Then mole per mole. Cut off. Now you have 95 grams. So, what is the mass of magnesium chloride produced? So you have to find it out. Magnesium chloride 1 mole as N equals simple M over capital M. Simple M is 95 grams. My next question. B. 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 How many magnesium chloride molecules are produced? How many magnesium chloride molecules are produced? Yes. The answer is 6.022 times 10 to the power 23. Explanation according to Avogadro. According to Avogadro, according to Avogadro, uh, 1 mole has 1 mole contains 6.022 times 10 to the power 23 molecule. Right. I'm going to modify the question. 1 mole of magnesium chloride is produced. I say if 1 mole of magnesium chloride is produced. Going to the other question, I will print it out. I use the question like here. I use the question. Given below is a chemical reaction. Use it and answer the questions. Magnesium with hydrochloric, magnesium chloride, hydrogen gas is produced. So I went on, and I'm going to make another question. That is the fifth one. See how far you are clever in answering this question. How far you are clever in answering this question. Right? If 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 2.4 gram of magnesium is used. If 2.4 gram of magnesium is used, simple A, how many magnesium atoms are there? How many magnesium atoms are there? So in that chemical reaction, 2.4 gram of magnesium is used. So find out the magnesium amount of magnesium atom. How are you going to find out? Now we know. As we could see here, in this equation, I showed you, right? I showed you magnesium, the reaction is this one. The contributing amount of magnesium in this chemical reaction is 1 mole. That means 24 gram is used, right? I showed you the relationship between that mass and the mole, N equal M over M. So 1 mole, the mass is the molar mass, right? And then the Avogadro's connection, if you consider 1 mole, 6.022 times 10 to the power 23 is there. Now what I'm going to tell you is, the mass is changed. Then you have to find out the number of moles available there. According to the number of moles, if you have 1 mole, 6.022 times 10 to the power 23 is there, are there. And if the mass is reduced, then you have to find out the number of moles. Then accordingly calculate the amount of the number of particular atoms or molecules available. And now what I am going to apply is that one. I mean, I have not given 24 gram now. Instead of that, I made it little smaller. I put 24 gram into 2.4 gram. 24, 2.4 gram. That means now you have to find out the number of moles. So number of moles can be calculated by using this one. How? Given mass is 2.4 and molar mass, can you see that? Yeah, molar mass is 24 gram per mole. This is square. And the number of moles can be calculated, right? So you have number of moles then, and then multiplied by that one with 6.022 times 10 to the power 23, because one mole has this one, and then the given amount of moles times that one. So finally you will get the total number of atoms or molecules available there. Could you understand what I said? Yeah.
Yes, sir.
Yeah. Now still I'm relying on one, and I'm going to change next time, and you have to answer alone the questions that I give you. Okay. How many atoms are there? So the relationship is that according to the equation, n equal m over m, right? You don't want to write these answers, but just for your knowledge, I'm giving. N equal m over m. M is 2.4 gram, and that's gram. Capital M is equal 24 gram per mole. So then N equals, what is it? 2.4 divided by 24. 0 point 0 point 0.1. So 0.1 mole, gram per mole once it goes to their mole. But my question is, how many magnesium atoms are there? Now, 1 mole of magnesium has 6.022 times 10 to the power 23 atoms. Then 0.1 mole, 6.022 times 10 to the power 23 multiplied by 6 or 0.1. What is your answer? 6.022 times 10 to the power 23 multiplied by 1 times 10 to the power -1. That means 6.022 times 10 to the power 22. Correct?
Yes, sir.
Correct or no?
Yes, sir.
Now, I'm going to give you totally a new question. To get the beginning, the middle, the end, you can watch this video, and then you can find it out. And this is the questions that normally I give you, because I took a magnesium story, but I'm going to change it. If you can answer this question, good, you are now perfect in this field. You are perfect in this field. If you want to see the whole story, what we discussed here, that's included here. That's included here. We started from there. Then something. Yes, yes. We'll go to the question. We'll go to our question. Question. Try to find your answers perfectly. Question. Question. Yeah, the screen. So then it will be super for you. Question. Major question. Given below is a chemical reaction. Given below is a chemical reaction. Calcium carbonate is heated up. Calcium oxide and X is produced. Calcium carbonate is heated up and calcium oxide and X are produced. Simple one. What is X? 2. Balance the equation. Balance the equation. Third one. Third one. What type of chemical reaction? What type of chemical reaction is given above? What type of chemical reaction is given above? Fourth one. If uh, mm, 5.6 gram of calcium oxide is produced. If 5.6 gram of calcium oxide is produced, simple A. Find the mass of CaCO3 used and mass of X produced. Simple B. How many CaO molecules are there? There. C. C. C part. How many moles? How many moles of X is also are produced? How many moles of X are produced? 5. Write one occasion where above chemical reaction takes place. Takes place. Is the above reaction exothermic, endothermic reaction? Seventh one. Right. One use of. Right. One use of. Right. One use of X used. X produced. 8. Write the equation write the equation of write the chemical formula chemical formula CaO no, chemical formula of the chemical compound when CaO mixed with water. Our given Yeah. Write your observation. Write your observation of the above chemical compound. Write your observation of the above chemical compound. It when it is mixed up with phenolphthalein, phenolphthalein solution. Simple A, simple based on the above observation. Based on the above observation, what conclusion? What conclusion can you come at the end? Right. It is your duty to answer the question. Can you answer the question? If you are a newcomer here, now, can you see the whole question? Can you read that whole question? Can? Too small. You can read, right?
Small, sir.
Too small. Is it too small?
Yes, sir.
Well, let me see. Okay, I'll try. I will try. Try. Now, let's see how far I'm clever in that one. Let's go. Let's see my effort would be successful or not. Yeah. For am I successful in now? Now you can read, right? Hello? මේ ළමයින්ගේ වචන හරි ගණන්. අර ගුවන්විදුලි සංස්ථාව වගේ. නේද? Yes, sir, we can see it now. It's like very expensive, these words, when you answer these questions. Can you see the screen now?
Yes, sir.
Cancer.
I want your feedback. Let me know.
Yes, sir.
How is the lesson today?
It is good, sir.
Excellent. Dasitma and Manilka. Are you okay?
Yes, sir.
And the answer is given by Manilka or Dasitma?
Maneka.
Manilka. Where's Dasitma?
She's Samuel.
Dasitma. Want to visit you both one day to have a cup of tea and come. Avisha. Avisha Dinet. The newcomer from Bandar. Who is that? Udani or is that Udani? Yashodhya Maitri. Yashodhya.
Yes, sir.
How is the class?
Good, sir.
Yashodhya, from where are you, Yashodhya?
Konotta, sir.
Huh?
Konotta.
Avindu. Head out. Head out. Bad. යන්ද උමයන්ගලගේ ගෙවල් කළුතර පැත්තේ උන්ට අපි කතා කරන්නේ නැහැ. Is it finished? Can I discuss the answers? You want a little time more? Finish your answer, Randunu.
Not yet, sir.
Okay. Finish? All right. Let's see. Udara, did you finish that? Finished it. Not yet. Savindu,
Yes, sir.
finish that.
Yes, sir.
Okay. Let's try to find the answer. Right. Do you think that this is easy or difficult? But difficult or easy? Some grade 10, some of you actually don't know because it is not in your syllabus. Given below is a chemical reaction, right? Now I'm getting it back because I want that space to write the answer. So I will get back. Right. The space, right. Given below is a chemical reaction. Calcium carbonate, calcium oxide, X. My question. What is X? What is X? I think that you might answer my question. What is X?
Carbon dioxide.
Yeah. Calcium carbonate, calcium carbonate, calcium carbonate. When calcium carbonate is heated up, calcium oxide and carbon dioxide is produced. Calcium carbonate and carbon dioxide is produced. So the answer for that one is carbon dioxide. Carbon dioxide is the answer. Carbon dioxide. Balance the equation. I think the equation should be balanced. Calcium 1, carbon, and oxygen 3. It is balanced. You can say solid, solid, and gas. What type of chemical reaction is given above? What is the answer for that one? What type of chemical reaction is it?
Decomposition.
Chemical decomposition. Decomposition. If 5.6 gram of calcium oxide is produced, right? Now, as I told you, we're going to find out N equal M over M by using that one to solve out that question. Now, before that, we want to find out the number of moles produced. the number of moles produced can be calcium oxide, 1 mole, this is 1 mole, 1 mole, 1 mole, and 1 mole. Each of them produce 1 mole if 1 mole of calcium carbonate is used. But 5.6 gram of calcium oxide. This says it produces it produces 5.6 gram. 5.6 gram, right? Find the mass of calcium carbonate used and mass of X produced. Now, calcium oxide, the first thing is that in this question, the very first thing in this question, what you have to do is, right, convert this one into moles. Convert this one into moles. Calcium carbonate, we turn into calcium oxide. So according to N equals simple M over capital M, 5.6 is used and 56 gram per mole. This is gram. You might know why I took 56 here. Calcium, because calcium, capital M of calcium oxide is calcium 40 and oxide 16. That together make 56. And that is what I use here. And the answer is 0.1 mole. 0.1 mole. Then 0.1 mole, 0.1 mole, 0.1 mole. So all produce 0.1 mole. And calcium oxide now. My question is mass of calcium carbonate used. So convert this one into M. M equal N capital M, because I can take N equals simple M over capital M and then subject simple M. When simple M is subjected, it makes simple M capital M. Then we can have simple N 0.1 and capital M calcium carbonate. Capital M, you have to find out that one. Calcium 40, carbon 12, 43, 48. 48. I think you have found out it. What is the final one? That should be 100, I think. Am I correct?
Yes, sir.
Yeah, then you have to multiply it by 100. 0.1 times 100. The answer is 10 gram, 10.0 gram. Am I correct? Yeah.
Yes, sir.
Same way, find out the mass of carbon dioxide produced. Again, the same way, N equal M over M. So you can have M equal simple N capital M. Simple N 0.1 and capital M 44. 44, we found out 44, something like this. 12 multiplied by 12 plus 32. That makes 44. So then you have to multiply it by 44. That means 4.4 gram of carbon dioxide will be produced. And my next question, how many, how may, find out the mass. How many calcium oxide molecules are there? How many calcium oxide under B? In that means 5.6 gram calcium oxide used in 5.6 gram number of molecules. So number of calcium oxide molecules. ඔයාලට පේනවා අඩුද මේක? ෂෙයාර් ස්ක්‍රීන් එකේ හොඳට පේනවද? Number of calcium oxide molecules. අපි දන්නවා 1 mole has 6.022 times 10 to the power 23 molecules, right? හැබැයි අපිට දීලා තියෙන්නේ the amount of moles here is 0.1 mole because we found out from earlier. Then 0.1 mole you can 6.022 times 10 to the power 23 multiplied by 0.1. That means you can multiply it by 6.022 times 10 to the power 23 multiplied by 1.10 to the power negative 1. So then 6.022 times 10 to the power 22 molecules will be there. Right. Moving to the other question. See, how many moles of X are produced? How many moles of X are produced? As we have already know that the amount of moles that carbon dioxide produces is 0.1 mole. We found it out earlier. The answer for that one is C. Part C, 0.1 mole. Right, 0.1 mole. My next question, write one occasion where the above chemical reaction takes place. This, of course, grade 10, you can't answer that one, but grade 11, you can. Where can you see this chemical reaction?
Last one.
Huh?
In last one.
Didn't hear very well. In iron extraction. In iron extraction, calcium carbonate is put there and turns into calcium oxide and carbon dioxide. You can see that it is taking place in iron extraction. Next question. I think I have to clean this one in order to get the space. Is it okay? I'll be cleaning this one, right? Otherwise, the space is not enough. Right. Is the above reaction is the above reaction exothermic or endothermic reaction? If it is endothermic reaction, it will not be used in the metal extraction, because in the iron extraction, we need to have more heat plus carbon dioxide. So the decomposition of calcium carbonate into calcium oxide and carbon dioxide will be releasing more heat energy. So it is an exothermic reaction. it releases heat energy. Is it endothermic reaction or exothermic reaction? Your answer?
Exothermic.
It's exothermic reaction. Again, exothermic. Exothermic reaction. Am I correct? Grade 11s.
Yes, sir.
Yeah, grade 11s. You know that. 10th will be learning in grade 11. Right, one use of X produce, carbon dioxide. You can't write for the plants to produce food, correct. But you know, the contextually what we are expecting is some other occasion. In fire extinguisher, to make dry ice, right? To make dry ice, make dry ice. Patents you don't know, but you may practice your ear. You may make your ear familiar with these stuff. You know, when you are learning things that you don't want to wait, you don't want to wait the time to come, but to fill up with heavy load of stuff of your brain, and you can have that, right? Like one user is produced. Write the chemical formula of.
Excuse me, sir.
Yeah.
So can't we write usually in extinguishing fires?
Yeah, I told you to use it in extinguishing fire. I told you earlier. There are some more uses of carbon dioxide to make dry ice, right? You can write one use of it. Write the chemical formula of the chemical compound when calcium oxide mixed with water. That means it will make calcium hydroxide, CaOH twice. CaOH twice. In grade 6, the very first chemical compound, right, you learn with lime water, calcium hydroxide. Write the chemical formula of chemical compound when calcium oxide mixed with water. Write your observation of the above chemical compound of 8 when it is mixed up with phenolphthalein solution. The observation that phenolphthalein will turns the calcium hydroxide into pink color. The color change. The color is changed. Color is changed into pink color. Pink color. That's A. B. Based on the above observation, like what conclusion can you come with? Yeah, calcium hydroxide is a strong base. It's a strong base, right? A strong base. How is that question? Are you happy about the proceeding up to today? Now? Yeah.
Yes, sir.
Are you happy about that?
Yes, sir.
Yeah. Okay, go into the other one. A small questions. Let's see how far you are clever in answering the questions like this. Let's go. Let's go. These are basic. These are basic. Question number 1. Oh, not details one. Okay. If Ca is 40. If Ca is 40, what is the molar mass of calcium? Of molar mass of 1 mole of calcium. 1 mole of calcium. If Ca is 40, what is the molar mass of 1 mole of calcium? The answer? The answer?
40 grams per mole.
Grams.
Yeah. If you write 40 grams, it is wrong. Why? You need to write 40 grams per mole. 40 grams per mole. I told you that's very simple questions, right? Number two. How many atoms, how many atoms are there? How many atoms are there in 0.2 mole of calcium hydroxide? How many atoms are there in 0.12 mole of, oh my God, it's a complicated one. How many atoms are there in, make a mistake. I'm not going to put in that much trouble. How many atoms are there in CaOH twice? How many atoms are there in CaOH twice? Your answer? Your answer? How many atoms are there?
6.02 times 10 to the power 23.
Are you sure? Are you sure? Any other answer? How many atoms are there in CaOH twice? Well, don't misunderstand that. I'm not referring to 1 mole. There's no any indications to show you that I'm talking about 1 mole. If it is 1 mole, there should be given mass or number of moles. So what you have to consider is in this molecule, Ca, 1 atom. Then OH twice means
5 atoms.
H multiplied by 2, that is 2 oxygen, 2 hydrogen, 2 oxygen, 2 hydrogen. How many altogether?
5.
5 atoms. 5 atoms. Am I correct? Am I correct? Yeah. අර ත්‍රිවිල් කන්ටේනර් එකක් කෙලවලා කරන කන්ටේනර් එක කෙලවන ඩ්‍රයිවර් කෙනෙකුට එක පාටම ත්‍රිවිල් එකක් දුන්නාම අනිවාර්යෙන් ඌ ඒක හප ගන්නවා. මොකද නේද? ඒ වගේ තමයි. We have done tough questions, right? We discussed tough areas. And immediately when I give you so simple question, you think in a way that the tough questions are solved. So that's why I gave you very simple questions like this. Okay, next one. How many atoms are there in CaOH twice? Right? What will be the, what will be the amount, A-M-O-U-N-T, what will be the amount of moles if if what will be the amount of moles if 6.022 times 10 to the power 23 amount H2 will be the amount of moles if 6.022 times 10 to the power 23 amount of hydrogen molecules are used. The answer,
One
what
more.
is 1 mole? 1 mole. It's 1 mole. And the fourth question. Fourth question. Fourth question. If Na is 23, O is 16, H is 1. Find out the mass of 0.02 mole of NaOH. If Na23, O16, H1, find out the mass of 0.02 mole of NaOH. NaOH. The answer, N equal simple M over capital M. Simple M I don't know. Capital M I know. I want to find out. Na23 plus 16 plus 1 would make 40 grams per mole. So what is N is given. N is 0.02. Now I'm going to put that together. So N equal M over M. Asking one is mass, that is this one. M equals simple N multiplied by capital N. Simple N is 0.02 multiplied by capital N. That's 40. This is mole. This is mole. This is mole. N equal N. This is 0.02 mole multiplied by 40 gram per mole. So mole per mole, and then 40 multiplied by 0.2. The answer is, what's the answer? It is, you can have 80 40 times 2 is 80, right? And the number of decimal is 2. So you have to get 2 decimals. That means 0.8 US. Am I correct? Correct or wrong?
Correct.
Correct, sir.
Yeah.
Excuse me, sir.
Yes, correct.
Sir, may our decomposition of calcium carbonate endothermic the exothermic the?
Exothermic neda. Endothermic the.
So endothermic නෙමෙයි heat එක ගන්න නැද්ද ඒක මේ calcium oxide වලටයි මේ carbon dioxide වලට කැඩෙන්නේ.
1 second. You are correct. I mixed up with calcium hydroxide, calcium oxide to calcium hydroxide. Calcium oxide with water, endothermic, the exothermic. The. Water take to mix up when it is endothermic. It should be endothermic. Uragan on it. I made that mistake. It should be endothermic reaction. Yeah. Calcium oxide, carbon dioxide. The decomposition of compound given other simpler compound elements, decomposition reactions. It should be endothermic reaction. Yeah. I get confused with this one. What is it? Calcium oxide with water. My mind was there. Calcium hydroxide. Is this endothermic or exothermic? Is this endothermic or exothermic? This is exothermic. ඔයක මේ හුණුගල් ගෙනල්ලා පුච්චපු හුණුගල් ගෙනල්ලා ඔකට වතුර දාන්නේ අපේ තාත්තට මට මතකයි පොළවේ වලලලා මුට්ටිය පොළවේ වලලලා ඒකට දාන්නේ. පැහෙනවා නිකන් ගින්දර දාලා වගේ පැහෙනවා. ඒක කරන්න calcium carbonate should be endothermic. You have to give the heat to break it. අපි ඒකේ උත්තරේ ලියුවා නේද? ඒක වැරදි නේද? හරි. කොහොමද කොතනද ලියලා තියෙන්නේ? දකින්න බලන්න. It should be endothermic. එන්න මෙහෙ ලියුවා නේද? කොහෙද ලියුවේ? ඔය වෙලාවෙ මතක් කරන්න එපා යා. මේක. කොහෙද තිබුණේ? මේකද? මෙතන. It should not be exothermic, it should be endothermic. This one, endothermic. Sorry about the mistake. අනිත් පුතේ ඒ වගේ දෙයක් on the spot correct කරන්න ඕනේ. මොකද මම ටිකක් මේ සංකීර්ණ ගේම් එකක් ගෙනියන්නේ මෙතන නේද? Like because I have never I don't have anything pre-prepared. When something is pre-prepared, that I'm following some guideline. So I don't like it because I have to give you whatever the things that I come and whatever the response you are come. කලින් ලෑස්ති කරගෙන පොළ කෑල්ලක් පොළ ටිකක් මෙතන තියාගෙන මේවා දාගෙන එහෙම කරන්න කැමති නැහැ මම. This is my style. එතකොට හැපෙන්න පුළුවන් වරදින්න පුළුවන් ප්‍රමාණය වැඩි. ඉතින් බුද්ධිමත් ළමයිත් එක්ක වැඩ කරන්නේ මේ දැන් කරා වගේ on the spot correct කරන්න. එතකොට ඒක සමාජගත වෙන්න. දැන් කවුරු හරි මැද ඉඳලා ගියා නම් එයා අරක එක්සෝතර්මික් කියලා හිතාගෙන යන්න. එන්ඩෝතර්මික් කියලා හිතාගෙන යන්න. එතනනේ. රෙකෝඩින් උත් හේකුත් යනවනේ. Okay. For today, that's the end. I think that's enough for today. Am I correct?
yes sir.
Did you enjoy my lesson today for 2 hours?
Yes, sir.
Yes sir.
Yes,
sir.
sir.
Yes, sir.
While of coming over here,
Yes, sir.
or yeah. Okay, then fantastic. And to end up the session, we have more revisions. We have more revisions, right? Calcium to finalize it. I must say, what is it? Decomposition of calcium carbonate into calcium oxide and carbon dioxide. This, the heat has to be given. This is endothermic reaction. Endothermic. Yeah. Okay. And thank you very much for watching, and see you. Anybody who wants to talk to me, 7181461183, or go to Bye then.
Thank you, sir.
Thank
Have a
you,
good
Yes
day,
sir.
sir.